Okay, we've replaced the FEG module and we have baked out the column and we've reinstalled the gun head and we've pressurized it with SF6. We're now ready to do the high voltage conditioning. To begin the high voltage conditioning, we come back here to the XP user interface and we find the adjustments page, and we're going to we're going to choose service number 40, and then we click the little plus sign and that brings up the service window, and we're going to choose conditioning, which brings up a little box that allows us to run the high tension up to 34 kV. But before we do that, we start at 10 kV and we're going to work our way down to 500 volts systematically and slowly. Now remember, I'm going to demonstrate this at a much higher rate than you would normally go. I've already done the conditioning on this column, so I can comfortably run through this fairly quickly, but when you've just changed your FEG module, you want to do this very slowly and cautiously, and while you're adjusting, you need to monitor your upper IGP pressure. And as you can see here, we got a very good pressure. We're at less than 4 to the minus 10 millibar. And anytime this pressure fluctuates during this high tension conditioning, it could be due to a mild arcing, or could be major arcing, which could turn off your high tension. That's what you need to be careful of. So what we're going to do is we're going to go down 1,000 volts at a time. And pause a moment, and then we'll do it again. Working our way down to 500 volts. Some people like to be a little more cautious and go at 500 volt increments. So we're working our way down. Keeping an eye on our upper IGP pressure. Everything looks stable here. Again, I'm going much faster than I normally would. Keeping an eye on our upper IGP, it looks good. .500 volts. Now, if this was the first conditioning you've done since you've replaced the FEG module, you'd let it sit here for about 15 minutes, but I'm just going to go ahead and start ramping it back up. We're going to work our way up to 34 kV. That's one thing that this conditioning function allows us to do, is to go to 34 kV. Normally you can only go to 30 kV, but for conditioning we'll go a little higher and we'll go to 34. So we're working our way up there. Again, I'm kind of accelerating the process. Just for demonstration purposes here. Don't want to waste a whole lot of time showing obvious things. So we can also just go straight to, oops, don't hit enter. Oops, I did it again. All the time we keep our eye on the upper IGP. It's not till we get above 25 kV that I'd really expect to see any action. Okay, so now that we're at 25 kV, I'm going to go up 1 kV at a time. Watch the upper IGP. Okay, there's 30 kV. (31 kV). 32 kV. 33 kV. 34 kV. Now we'll let it sit for a half hour and the high voltage conditioning is complete. After you let it sit for a half hour, then you can run it back down to 10 kV. Our upper IGP is looking great. Run it down to 10 kV, turn off the high tension, exit. And now we're ready to move on to the next step, which is starting the source. Okay, we're ready to start the source. We start by going to the service window, which is right here, and we click that, and the little service window appears. And now we want to set some parameters. We want to set our extractor. We want to set that to 500 volts. And we want to set our filament to 2.43. This is the number you want to find on your data sheet. It's not always 2.43. It's usually pretty close to that number, but on the little data sheet that comes with your FEG module, there will be a filament current, and that's the number you want to enter here. It's very important. So enter your filament current parameter, and once that's filled in, then we're going to hit exit, and we're going to say no. And now we're going to come back over here and turn the source on. And when we turn the source on, this little dialog appears. As it's ramping up the filament current and extractor voltages. And this will take a while. It goes very slowly. And when that's complete, we will start the next step, which is manually ramping up the extractor voltage to get the emission current we're looking for. Okay, it's been a few minutes and you can see we're almost complete. The gun change dialog is almost finished, showing that the extractor voltage and filament currents have been ramped up, and when it's done then it disappears. And now we will ramp up the extractor. We go to the service page again, and we're going to adjust the extractor, and we're going to monitor the emission in P90 test, DAX, HRDS, and we're going to set it to continuous back gun, and we're going to also set our VC1 well, it's a good low number already. We'll leave it there. So the extractor, we're going to start increasing that number. And as we're doing that, oops, pardon me, I gotta ramp up the high voltage first. And we're going to adjust our extractor while we're monitoring the emission current right here. This emission current value we want to watch, and we also want to watch this emission current value, and we want to watch our upper IGP to make sure nothing is indicating any gas bursts. So we're going to go up in 100 volt increments. This is a slow process. You can see we just got a little bump up in our emission. And we're getting an increase in emission current on our electron page as well. No action in the upper IGP, that's good. Everything's looking normal. We do this slowly and methodically to be able to detect if there's any problems. One thing that we want to avoid is a gas burst that can contaminate our nice little sensitive Schottky emitter. We do see the pressure rising in the upper IGP during this process. We need to pause and let it recover. So in the HRDS, the emission current we're shooting for is 8 microamps. As you can see, we've got a long way to go. But you'll notice as you adjust this that it'll start getting more and more sensitive. And instead of making 100 volt increment adjustments, you're going to be going down to 5 volt adjustments. Okay, everything's looking very normal here. Very good. Very good. So I'm going to continue with 100 volt increments for a little bit longer. Okay, now I'm going to start 50 volt increments. Things are looking really good. Yep. Okay, looking good. 50 volt increments. Emission current is reading 4.222. Upper IGP is still solid. Okay, we're getting there. Very nice. I'm going to go up in 20 volt increments now. Getting there. Upper IGP is nice and stable. Very good. Just a little more and we'll be there. Okay, this is when I start going to 5 volt increments. Oh, we're so close. Okay, I'm going to call that good. We're not quite at 8, we're just shy of 8, but just want to make sure that it stabilizes and doesn't drift higher. We'll come back later and adjust it. You'll find with a new FEG, your settings will drift a little bit, and you'll have to give it maybe as much as an overnight session before it will actually be really stable at an emission for a given extractor voltage. So we're going to stop here, and okay, so we've let the emission current stabilize, and it is looking nice and stable there, and we have our final extractor voltage recorded, and so we are done with this HRDS dialog box. We can close that. We can turn off our high voltage for now, and we can begin our coulomb tube conditioning procedure. So the first step is to disconnect the power to the coulomb tube, and that is right here. That's DDB X40, the DC distribution board connector, where the power to the coulomb tube supply comes from. We disconnect that. So we've disconnected the coulomb tube power supply. Now we can come over here and adjust our accelerating voltage. We want to start at 10 kV, but we want to use spot 1. And now we can turn on the high voltage. And what we're going to do is slowly ramp the high voltage down to 500 volts, and we're going to be watching the upper IGP pressure, of course. So 9, 8, 7, oops, pardon me, 8. We got a little pressure rise there. Not very significant. So now we're at 500 volts. You see, we got a little bit of a pressure rise out of the upper IGP, but that's not very significant. And now that we're at 500 volts, spot 1, we can go over here to our other dialog box, and we can make changes to our VC1 voltage. We're going to start at 1400 volts, and we're going to pay very close attention to the upper IGP with this adjustment. We'll let's bring these boxes down here close so we can see things a little better. So I'm just going to slowly ramp this up. And I'll let you know I've already done this adjustment, or all this conditioning procedure, so we're not likely to see much here. So I'm going to go a little faster, much faster actually than I normally would, just to demonstrate the procedure. But this should be done very carefully, watching the upper IGP pressure. You do not want the upper IGP pressure to exceed the mid -9s. Millibar, in the millibar range, so be very careful. You don't want to contaminate the Schottky emitter. It's very sensitive, and that's what we're trying to avoid by preventing gas bursts. And we're working our way up to 4,000 volts. When we reach 4,000 volts, we'll be done. So as you can see, the system's very clean. But watch very closely, because you can generate gas bursts fairly quickly. If you do see a gas burst, stop advancing the voltage, and if necessary, if it takes a while for the vacuum to recover, then reduce the voltage. Working our way up to 4,000. Oops. Accidentally pushed enter. I don't want to do that. Okay, we're not getting a whole lot of action out of this, but that's a good thing. It's not unusual to see substantial gas bursts here in the upper IGP that require you to stop advancing the voltage and wait for a recovery. Alright, here we are at 4,000 already. Okay, that's the coulomb tube conditioning procedure. This was just a demonstration. If you were doing that yourself, you probably would have gone much slower, and you would have had to see substantial gas bursts here that you would need to let recover before you could proceed. So anyway, now that we're done with this, we can exit, and we can prepare to proceed with the rest of our column alignments.